Okay, so today we're going to take notes on 4-4. Let's see. This is called determinants and inverse. Okay, determinants and inverses. So we're still talking about matrices. Okay, this is just another way to solve for inverses and determinants using matrix. Okay, so let's see. A real number called a determinant is associated with each square matrix. Vertical bars are used instead of brackets to indicate that we are to find the value of the determinant of the matrix. Okay, so instead of using brackets like we have been like this, now we're going to be using just, it almost looks like absolute value, right? They're just vertical bars going up and down. Okay, so that's how you know that this means determinant. Okay, this is just a regular matrix. So to find the determinant of a 2x2 matrix, okay, if A is equal to your matrix, you have your brackets A, B, C, D, okay? Then the determinant of A is equal to, now you have your vertical bars, A, B, C, D, which is the same. They're in the same order, see? With the vertical bars going down, okay? But to find the determinant of A, what you're going to take is you're going to take your A times D minus B times C. Okay, so you're cross multiplying. So A times D minus, your sign in your, you need to remember is minus B times C. Okay, so now let's do the first one. Evaluate each determinant. Okay, so what are you going to have? So these straight lines are telling you need to be finding the determinant of this matrix. Okay, so you would have 3 times negative 2. That's A, and this is D, minus B, C. So 5 times 1. So you're going to get negative 6 minus 5 equals negative 11. So the determinant of this matrix, the answer is negative 11. Okay, so now for this one, you would have negative 1 times negative 2 minus 4 times negative 3. So you would get negative 2 times 1. Negative 1 is positive 2. And then you're going to have negative 4 times negative 3, so you're going to have plus 12. So it would be equal to 14. So the determinant of these numbers, of this matrix, is 14. Okay, so now let's talk about inverses, because you use the determinant to help you find an inverse of a matrix. Okay, so first off, inverses, it's just trying to show us, so it wants us to multiply these two together, just like we've learned in the past. Okay, so you're going to take your first row and multiply it by your first column. So you're going to have 1 times 11 plus negative 5 times 2. Okay, then you're going to take your first row and multiply it by your second column, and you're going to get 1 times 11 plus negative 5 times, oh, sorry, not 1 times 11, 1 times 5 and negative 5 times 1. Okay, now second row times first column, negative 2 times 11 plus, negative 2 times, what? Yes, that's right. Negative 2 times 11. And then 11 times 2. Okay? Now you're going to take your second row times your second column. So negative 2 times 5 plus 11 times 1. Okay? So now let's go on ahead and see what we get. So you're going to get 11 minus 10. It's going to give you 1. You're going to get 5 minus 5, which is going to give you 0. You're going to get negative 22 plus 22, which is 0. And then you're going to get negative 10 plus 11, which is 1. Okay? So we get 1, 0, 0, 1. So it says, if the product of two square, which is an n by n, this is an n by n, this is an n by n, matrices is the identity matrix, the two matrices are called inverse matrices. The symbol A, negative 1, is read the inverse of matrix A. okay? So this is called your identity matrix right here, okay? That's what it's about to talk about. So when you get 1 and 1 and you get zeros on the side, that's called an identity matrix. So it basically took these matrices are inverses of each other. And so when you multiply them together, you get an identity matrix, okay? So the identity matrix is a matrix with a diagonal of 1s, okay, like this one and this one, and the rest of the elements are 0, okay? So when you multiply two matrices together, if you get this as the answer, then you know they're inverses. All right. So let's look on the next page. Determine whether the matrices below are inverses of each other, okay? So it basically wants us to multiply these two together, because we know if we multiply them together, and if we get an identity matrix like this, if we get this for the answer, then we know they're inverses. If we get something else, we know they're not. And it's asking us if they are. So we're going to multiply these together. 5, let's see, I'm not going to rewrite the whole thing, so let's just do, you're going to have 5 times negative 3, which is negative 15, and 2 times 8, which is positive 16. Then you're going to have 5 times negative 2, which is negative 10, and 2 times 5, which is positive 10. Now you're going to have 8 times negative 3, which is negative 24, negative 3 times 8, which is negative 24. Then you're going to do your second row times your second column, which is going to be 8 times negative 2, negative 16, and negative 3 times 5, minus 15. Okay, so now let's see what we get. Negative 15 plus 16 is 1. Negative 10 plus 10 is 0. Negative 24 minus 24 is negative 48. And negative 16 minus 15 is negative 31. Okay, so that is not equal our identity matrix. So no, the answer is no. They are not inverses of each other. Okay, it says to find the inverse of a 2 by 2 matrix where A to the negative 1 equals 1 over the determinant of A times the matrix D negative B negative C A. Okay? And you saw a while ago when we started, if you look up here, this is A, B, C, D. So you flip A and D. That's what they did right here. They flipped A and B, and they made the B and the C negative. Okay? It says if the determinant of A, which you're going to find right here, is 0, then there is no inverse. So you don't have to do anything else. Like once you find your determinant of A, if you get it equal to 0, you don't have to do anything else because there is no inverse. Okay, so it says you must find the determinant first. You must find the determinant first. Because if you know it's 0, you don't have to go any further. Okay? So now let's write out how we would find this one. Okay? So we're going to put it in this form. Here is your matrix, and it's at this negative 1 means it wants you to find the inverse of this matrix. Okay? And to do that, you have to follow this formula up here. Okay? You have to follow this formula to solve it. So you're going to have 1 over. First, we need to figure out what the determinant of A is. What did we say a while ago? We said it was going to be A times D minus B times C. That's what we had, right? A, B minus, A, D. Can't even think. AD minus BC. This is determinant, equals your determinant, okay? So what are we going to have? Negative 9 times negative 3 minus 5 times 6. So you're going to get positive 27 minus 30 equals negative 3. Okay, so that's our determinant. Determinant. Okay, so 1 over the determinant of A, so that's where we put negative 3. Okay, it's right here in the formula, 1 over determinant of A. Okay, so now let's rewrite the matrix. And where D is, we're going to flip these two, which is A and D. So we're going to move this one up here and this one over here. So you're going to have -3, and then you're going to put the -9 down here. Okay, because that's what the formula is telling you to do, right? A, B, C, D, it's telling you to flip these two. And now the formula tells us to put negatives in front of our B and our C. So it would be -5 and -6. They stay in the same place, they just become negative. So now we need to solve it. Okay, so -1/3 times -3 is +1. -1/3 times -5 is +5/3. -1/3 times -6 is going to give you a +2. And then -1/3 times -9 is going to give you a +3. So this right here is your answer. Okay? That is the inverse of this matrix. This is the inverse matrix of this matrix. Okay, let's do one more. Let's see, let's look at this one, okay? So first, you need to find your determinant because it's 1 over your determinant of A. So your determinant is going to be AD, 6 times 8 minus -16 times -3. So -16 times -3. So you're going to get 48 minus -16 times -3 is +48. So you're going to get 48 minus 48 equals 0. So your determinant is 0, right? So we don't even have to write the rest of it out. We know the determinant is 0, and when it says the determinant is 0, then there is no inverse. So the answer is no inverse. Okay. All right. We'll do number 7 in class together, okay? But it works the same way as number 5. You're going to use the formulas up here to solve for the inverse.